Now let us do class 11 chapter system particles. In that, rotational motion. And this is first class. In that we are doing center of mass of two particle system. When we talk about center of mass, it means in general the point lying inside or outside a body where entire mass is supposed to be existing or supposed to be lying. The word supposed to be significant means actually such mass does not exist there, such mass does not lie there, entire mass cannot lie at one point, but it is mathematically convenient point. अगर हम ये फॉर्मूला फाइंड करने की कोशिश करें तो xy plane में we assume that at A and B we have two masses m1 and m2 having position vectors r1 and r2. Initially in general masses रेस्ट में है दोनों. अगर हम इन पे फोर्स लगा दें F1 एंड F2 तो मास में हम मोशन प्रोड्यूस कर सकते हैं और एज्यूम करते हैं कि V1 एंड V2 उनमें वेलोसिटी स्पीड हमने क्रिएट कर दी. जब वेलोसिटी या स्पीड हमने क्रिएट कर दी तो जहां भी फोर्स है और वेलोसिटी है तो सेकेंड लॉ ऑफ मोशन कम्स इनटू पिक्चर. सो फ्रॉम सेकेंड लॉ ऑफ मोशन we can write the net force on both F can be F1 plus F2. And then from Newton's second law of motion, net F can be dp1 by dt for m1, dp2 by dt for m2, which is F1 plus F2. Now d upon dt is common, so p1 plus p2. Now d upon dt, momentum we know can be m1 v1 plus m2 v2. That would be p1 and p2. Now we know the velocity in terms of position vector as dr upon dt. So F is equal to d upon dt. M1 v1 is dr1 by dt plus m2 dr2 by dt. Now again we have d upon dt can be taken common. So 1 d upon dt is existing and this d upon dt is common. So d upon dt into d upon dt. And so m1 r1 plus m2 r2, which means d2 upon dt square and within the bracket m1 r1 plus m2 r2. अब हम क्या करते हैं तो मल्टीप्लाई और डिवाइड कर देते हैं RHS को किससे m1 plus m2 से, means total mass of the system, and that way we get F is equal to m1 plus m2 d2 upon dt square m1 m2 plus m1 r1 plus m2 r2 divided by m1 plus m2, which is equivalent to total m d2r by dt square, because we know d2r by dt square means d, we write velocity in terms of position vector v as dr by dt and acceleration can be dv by dt, so it becomes d2r by dt square. And from this we write rcm as r1 m1 r1 plus m2 r2 divided by m1 plus m2. On the axis we can show it like if O is the point, and thus this becomes RCM. So this becomes formula. With this formula, special case is also important. So let us add important cases. When we add a special case, there are three cases with it, right? Case 1, when center of mass lies at its center or center of axis. Special case or cases. 1. When a COM center of mass lies at origin. So अगर origin पे lie करे, it means RCM is 0 और RCM को हम equate करते हैं M1 R1 plus m2 r2 divided by m2 r2 divided by m1 plus m2. So we can write m1 r1 is equal to minus of m2 r2, or m2 r2 is equal to minus of m1 r1. What we learned from this? It means one of the particle, like we have this m1 r1, one is lying left side of the origin. This minus sign shows this one, that m2 is lying left side of origin. Now if we take the second case, the second case could be when m1 is more than m2. Then we can have RCM as, or better we do like this. The previous expression if we use, then it becomes product of m1 r1 is equal to minus of m2 r2. Since we are taking m1 is more than m2, which means r1 is less than r2, and thus center of mass is lying closer to the m1. So whatever is bigger, center of mass will be closer to it, which means in case of the sun and moon, sun is bigger as compared to the moon, so the center of mass will be closer to the sun. Similarly, if we take m1 is equal to m2 is equal to m, then RCM can be m common, r1 plus r2 divided by 2m, m gone. Therefore, this RCM is r1 plus r2 divided by r1 plus r2 divided by 2, which means this center of mass is lying at the midpoint of the line joining these two objects. Right? Hope you have understood. Thank you so much.